Hello.
Yes, miss. Okay.
Okay. Okay. So we will do diffusion, right?
Yeah.
Okay, what do you mean by diffusion? Heard about it?
Yes.
Diffusion?
Like when
Yes.
something like a gas or a liquid diffuses into the air or a liquid.
Yes. So there is an experiment. We have one crystal of potassium permanganate. Potassium manganate. So potassium manganate is the color is like this one. This is a very deep uh, purple, I could say. Okay. Now what you are doing, you are taking a beaker full of water and you are putting this inside. So since this is a salt, it will start dissolving, right?
Yeah.
It will start dissolving in water, and the color of potassium permanganate will s- slowly spread all over the place. Correct?
Yes.
And what we need to understand, there is no water current. There is only kinetic theory, which explains that the particle of the crystal gradually move into the water and mixed the water particles in the inside the system. Now this is called dissolving. This is called, the term is dissolving. We
Exactly.
know dissolving. We know dissolving, right?
Yes.
Dissolving of, this is K manifold. The formula is K manifold. KMNO4. So this KMNO4 is going to dissolve, and this is called diffusion. So what is the thing? See, this KMNO4 is having higher concentration, correct?
Yeah.
Now, when it comes to contact with water, the water are having lower concentration.
Lower concentration.
So this higher concentration is moving towards the lower concentration in order to make a homogeneous solution, correct? So this process is known as diffusion. This process is known as diffusion. Okay,
Mm.
got it?
Yes.
Yes, any problem?
No.
Okay. Do you have any book you can read from there? This is very easy.
Yes, I do have the book. Which page?
The page number, just a second, 16. The same Pearson book we are using, right?
Yes.
Okay.
16?
Yes, it is there in 16. Maybe the version might not be the same. You could find diffusion experiment, this one. Done?
Miss, it's not there on page 16.
Okay, maybe our version, my version and your version is different.
Maybe.
I Yeah. Okay, so you search this heading, you will get it. Okay. Take your time, you search, and you will get this. The first chapter is the same, right?
Yeah.
Yeah, so you will get this. Maybe there are different version of the book, right? With different editions. So maybe the page number get altered. Okay. Okay.
Okay.
Okay. So what I am doing, this is beaker, and I am just placing one paper, and this is another beaker. So this is upside down. Okay, this beaker is upside down. So it is carrying blue color solution, and this one carries red color solution. What will happen if you remove this? If you remove this, what will happen?
The blue will dissolve into the red.
Okay. So if you remove this blue and this red is going to mix gradually, correct? And if they mix, they will form a same color, homogeneous color, right? If it is blue and it is red, so there will be in between the color. I don't know which color it will form. If you love painting, you know it. I don't know. Okay. So if you are placing it, it's not going to mix up. When you are removing it, they are coming into their contact and uh, they will form a mixed color. The same way, the same way when you are mixing gases, suppose you are having one jar full of bromine gas. This is your bromine gas. It should be in the downs. Sorry, just a second. So there is a jar full of hydrogen gas. H2 gas is colorless, you already know, right? We cannot see H2, hydrogen.
Yes.
It's there in air. Can we see? No, we cannot see anything. Now we
No.
are having a bromine gas, which is about a color of brown. Yeah. Okay, now this is Br2 bromine gas. It took 24 hours to mix. If this is hydrogen and this is bromine, you have removed the lid between them and now they are mixing. So they are gradually mixing. Correct. They are not like mixing. We are not giving any mechanical energy. We are not stirring it. We are just putting it together and gradually they mixed. And the brown color of bromine will reach up there, but a fade color will there. So what is the conclusion of this experiment? When you are putting two different colors together, they are mixing it without putting any effort. It means they are having their inner tendency to flow, and because of the flow they are mixing, right?
Yes.
Okay, the see, this is a gas, so it is a very usual behavior to go up. So why hydrogen is coming down? See, gravity doesn't work with any gas. Okay, that's not the case. So any idea why it is coming down? If bromine is there, I know bromine is light, so it has the tendency to go up and combine with hydrogen. So why hydrogen is coming down? You got my question?
No,
Huh?
no,
Okay, my question is
no,
bromine.
ma'am.
Bromine is lighter. so it will go up. This has the tendency, but the problem is hydrogen is more lighter than bromine, so why it is coming down and they are forming a homogeneous mixture after 24 hours. 24 hours. So why do you think hydrogen is coming down? The tendency for Br2 is very much fine. It is going to up. By why hydrogen is coming down? My question is about hydrogen. Okay, let me tell you. See the hydrogen which we have here, the hydrogen. Okay, so it is coming down due to motion. This is called random motion. This motion, the gases are always in random motion. Random motion means no direction motion. So the molecule may go this side, this side, this side, this side, anywhere, even down. Are you getting my point? There is no specific direction where the gas is going to flow, or maybe right side, maybe left side, no, anywhere. So you can expect hydrogen going this side, you can also expect hydrogen going this side. So because of that, the hydrogen is also coming down and Br2 is also going up and they are gradually mixing. But since this is a random motion, we cannot expect they will mix uh, instantaneously. So it takes a bit to mix all those molecules together. So it takes 24 hours to mix properly. Are you getting my point?
Yes.
Okay, so what are the condition if we want to mix them instantaneously? So what are the condition if we want them to mix? What will be the condition so they can mix uh, instantaneously? What are those conditions? I'm saying conditions. It means they are more than one condition. There are more than one. Okay. Okay. So what if you give high temperature? Children, kinetic energy, sorry, kinetic energy is directly proportional to temperature. If you increase the temperature, the kinetic energy of the molecule will increase. And what do you mean by kinetic energy? Kinetic energy is the energy when anything move, even you move, you will possess kinetic energy. Any particles which moves possess kinetic energy. Okay, so kinetic energy here is increasing. It means the motion of the molecules will increase and the random motion will also increase. Of course, that one is the same. So if they increase the speed, they will going to mix early. Hello, are you getting my point? Hello, hello. Uh,
Yes,
are you
ma'am.
understanding? Are you understanding, everyone?
Yes.
Yes.
Yeah.
So because of the higher temperature, they are going to mix together and they will mix rapidly because of the high temperature. Any other source, if you provide, it will going to mix. If we can shake it, suppose you are this is your hand, this is your hand, you are covering it, these two lids, and you are going to shake it. So they will mix, of course, right? So we call it mechanical force. We call this as mechanical force. Got it? So after mixing, or when we allow both the gases to mix for 24 hours, so what we are doing, we are separating both the jars. We are separating both the jars, and sorry, what I did. And we are just moving it upside down. Uh, there is no option for rotation. No? Bad. We're not able to rotate it. So sorry, I'm not able to rotate this. What we will do, we will allow hydrogen, we will allow one burning candle or something inside. If we allow something which is burning, suppose this is burning, when you are putting this inside, so the what is the what is the um, property of hydrogen? If you allow any ignition, it will start burning. Hydrogen is flammable, correct? That's why hydrogen, liquid hydrogen, used in rocket as a fuel. Remember? Do you have this idea? So hydrogen is having a tendency to burn with a sound of like popping sound. Okay, so when you allow one matchstick or something inside, it will start popping and it start burning, and it will burn in both the jars. So what is the condition? See, if you are allowing this uh, mix together and you are separating after 24 hours and putting one matchstick inside, it will start burning with a poppy sound. Okay, are you getting my point? So it means that hydrogen is present in both the jars. It is also evident that both the jars carrying hydrogen and Br2. Br2 we can see that the color will be there, but hydrogen we cannot see. So we will try with a matchbox. If it is start popping and igniting inside, so it means hydrogen gas is there. Okay, okay. Any question?
No, ma'am.
Okay. Everybody join? Yes. Yes. So, any question? No question? Okay. Okay. Now we will do solubility. Solubility. What do you mean by solubility? Anyone having any idea about solubility? Okay. Any idea about solubility? No. This is water. We have filled this jar with water, but the water is already measured. The water is 1000 gram, or you can say 1 kg. It is equivalent to 1 kg, right?
Yes.
In your book they have taken 100 gram, so let's write this. Let's follow your book only. Sorry, this is 100 gram water. So how will you measure 100 gram water? Water is a liquid layer, so how can you measure in liters, or sorry, in grams? What is the possibility? Like how would you measure 100 gram water? The question is not coming in your mind. I have written 100 gram water. Water is liquid. How will you measure in grams? Okay, we have done this a lot. In my chemistry lab, we have done it. Suppose this is a digital measuring machine, weighing machine. So here you are putting your beaker. It should be clean and dry. There should not be any kind of water or something inside. So the weight will be different. Okay, so you are putting it there, and there are few buttons. The buttons here will be tare. Tare. Tear. So when you press the tear button, the indication of the weight here if it is indicating, it will become 0, 0, 0, 0, 0. Okay, so now you are putting drop wise water inside this beaker. And when the reading comes to 100 gram, then you have to stop that moment. Are you understanding, sir?
Yes.
Okay. So how will you measure 100 gram? The same way you can measure any liquid. Putting a beaker and making it a tear, you need to press the tear button. The tear button will allow all the masses become 0. Okay, so when you are putting drop wise, you have to be very careful. It is difficult to get 100. Suppose you are getting 101 or 99. So if you put a larger drop, then you will get more, right? And if you are going to remove it, the water, so it is also going to contaminate the thing, the system. So that has to be very carefully done. Now you are taking 100 gram of water here, and any one of you, I will not tell, I will not ask any name. So any of you, Afnan, Takia, Tariq. So any of you having any favorite salt, any salt, or you know any salt, not favorite maybe.
Sea salt?
Sea salt. Okay, but here I'm asking about the formula. Suppose NaCl, KCl, Ki, AgCl, these are the salt for chemistry. And for normal life, you are having sea salt, you are having mineral salt, table salt, NaCl, correct?
Yes.
Yeah, so any salt you could say a name. Let's take NaCl. Any problem?
No.
I huh. Okay, now this salt, it's like the solid. Have you seen NaCl, the table salt at home?
Yes.
Yes. So you are taking these salts. Let's take this salt in a solid form and you are dissolving in water. So what will happen? The salt will dissolve and it will vanish. Have you seen chunks of NaCl in water? No. So
No.
we saw that the entire salt becomes vanish. Again you are putting salt, more salts you are putting inside. So what you will see that after 38 gram, when you have added NaCl, after 38 gram, the salt is not further dissolving. The salt is not further dissolving and the solution is become saturated. And we have noted down the temperature, which is 40 degrees Celsius. Earlier only we have noted down the temperature. Now after dissolving 38 grams of NaCl at 40 degrees Celsius, the water is not taking any of the salt. If you are putting more salt, it is going to be like there at the bottom of the beaker and it is not dissolving. You know what is the name of this phenomena? It is called solubility. The number 38 you are getting is the solubility amount, soluble amount. So what do you mean by solubility? The amount of NaCl, here NaCl act as solute and water will act as solvent. Okay, so the maximum amount of solute dissolved in solvent at 40 degrees Celsius in 100 gram water, it is called solubility. Okay, so I'm reading the solubility definition from your book. Please follow with me and please follow this. And if you have any question, you can ask. Okay, a solution is formed when a solid known as solute dissolved in liquid known as a solvent. See these two lines. Any question? Do you want me to repeat these lines? A solution is formed when a solid known as solute dissolve in liquid known as solvent. The solubility of a solid or solute is defined as number of grams of that solute dissolved in 100 gram of solvent at a particular temperature. When no more solute will dissolve in the solvent at a particular temperature, the solution is called saturated solution. Okay, hello. Do you have any question? We have few terms to understand. Yes, sir. Please ask.
No,
No.
Okay. First, we need to understand solubility. Sorry, the handwriting. Solubility, solute, solvent, saturated solution. Solubility is the process where solute is dissolving in solvent at a specific temperature and form a saturated solution. What do you mean by solute? The salt which is dissolving is known as solute. What is solvent? The salt is going to dissolve in water. Water is known as solvent. What is saturated solution? The further addition of solute is not going to dissolve in the solvent. So that particular solution is known as saturated solution. So we have learned these terms. Okay. Any problem?
No.
Okay. So my question will come. See, it's not my question. It is a very common question. The question is 38 gram, the the solubility of NaCl at 400 at 40 degrees Celsius is 38 gram per 100 gram water. What do you mean by this sentence? Can you explain this sentence?
does it mean that
Yes.
40 degrees Celsius for every 100 grams of water, I can only dissolve maximum of 38 grams of NaCl before the solution becomes saturated?
My God, this is perfect. Amazing. Very nice. You have done good job. May I know your name? Let's see.
Takia.
Okay. Amazing. Very good. Okay. So, got it? Everyone?
Yes.
Okay. So, let's move to the next part. Solubility curve. Um, Curves, actually. What do you mean by solubility curve?
No idea.
No idea. Okay. So, have you noticed here the temperature is mentioned everywhere, right? Okay. At your home, I hope everybody keeps fasting, right? I also keep fasting. So in my home place, whenever we fast, my mother make one special drink. Um, it is a sugary drink. See, she put water and lots of sugar, and there is a thing called ruabza here. It means rose syrup. So she add rose syrup. Okay, so we make this drink, and it is a very traditional drink for this particular place. So when I was very small, so my mother keep asking me to heat the mixture for sugar water, to heat a bit, so all the sugar will get dissolved in water easily, so you no need to give extra hard work, and later you keep it in the freezer, so it will be like chill. So I was not understanding why we are, if we want to keep it cool, so why we are heating the sugar earlier when I was very small. So later, when we have studied chemistry, we have learned that the temperature is a very big factor of solubility. Temperature is one of the impactful impactful factor for solubility. For solubility. If you change temperature, if you increase temperature, we will expect that the solubility will increase. Correct? Yes or no? With my example, you will
Yes.
see that
Yes.
when you are dissolving the particular thing and you are increasing the temperature, the solubility is increasing. But this is not the case for every salt. Every salt is different. See, every human is different. Okay, so our parents or sometimes teacher also thought that if you beat a student or scold a student, they will start learning more. But do you think this is the same case for every student?
No.
Right? If you scold a student, you are not studying, you are not, why you are not studying and all, they will lose hope. Correct? And they will not study. But if some student, if you scold them, they will start studying more, maybe because of the fear, or maybe they need that push from some person. So the students are even not same, so how do a chemical will behave same? Correct? So some salts, they are very much soluble, and if you increase the temperature, the solubility will also increase. But few behaves very differently. When you increase the temperature, the solubility will decrease. Don't you think it's a bit very confusing? Do you find it confusing? Yes, it is confusing. How will you understand which, if you increase few solid, the temperature, the if you increase the temperature, few solid will start increasing or decreasing? If I write KCl, without knowing KCl, how can you give the answer? Tell me. Right. So there is no particular way to understand. So scientist was also very confused how to understand this problem. So they have made a curve. Curve means it is not one thing or two thing. It's a curve of each. Let me see. Just a second. Let me draw the curve so you will understand better. Grams of solute per 100 gram water. Okay. And here the temperature. Temperature. Okay, temperature. So if you are drawing this solubility curve for Kn3, It looks like this, KNO3. Fine. So what does it means? It means that if you are increasing temperature, initially the temperature will increase, the solubility will increase very slowly. But after a certain point, it will increase rapidly. Am I right? See here, the distance is very less, right? Distance is very less. But suddenly, at this point, the distance become very much. Am I right? So here the slope is very different. It means there will be a rapid increase in solubility with temperature. So when we are drawing this kind of curve, we are examining the gram of solute which is dissolving in 100 gram water at different temperatures. So we will get the curve which is known as solubility curve. Okay. Any question?
Miss, can you repeat that again?
Yes, I will. Here we have plotted temperature. So see, this is 0, this is 10, this is 20. Along it will be 100 degrees Celsius. Now we are increasing temperature. So in every temperature we have calculated how many grams of solute has been dissolved in 100 gram of water. So each point we will plot this. Okay, we have a plot. So when we have seen the plot how it is moving, when we have drawn all the lines on the with the points, so we will see there will be a curve. Curve means a line which is not a straight line, which a line which is curvy. It means it is be a little round. So this is curve. So this curve signifies that how many, suppose at this is 20. So at 20 degrees Celsius, here this is 20. So at 20 degrees Celsius, how much amount of this KNO3 is dissolved? So if you can draw this line, so you will get the how much amount, how much it is dissolving. So solubility curve is the amount, is showing how much amount of KNO3 in 100 gram of water has been dissolved at particular temperature. So this is called solubility curve.
Oh, okay.
I hope you have understood.
Yes.
If you have any question, you can ask me. Okay. So in a question, they are asking us to draw a curve. To draw a curve. Okay. You know how to draw a curve? You have a skill. You just see. I'm taking a ruler. I'm taking a ruler. Now it is very. In the question, they have given one table. I'm drawing the table. Okay. Here, this is your temperature in Celsius. This is amount of solid dissolved. Okay. Here the temperature is 20. The amount of solid is 10. Here it is 40. The amount is 13. Here this is 60. The amount is 16. Now this is 80. The amount is 20. This is the last reading. Okay. So temperature we have plotted in this part, and here the amount of solid. So I'm just writing amount. of solid dissolved. Now, how to understand the scale? So we need to divide this in different sections. So again, we need the ruler. We are taking the ruler. Where is zero? Oh yes, this one is zero. So let's this as zero because this is the origin and we need to put zero in origin. Okay. So the red color I am taking. See, this is what 10, 20, 40. So it is coming in 20 divisions, right? So every one, this is called one, right? One, it signifies every one unit, this signifies here it will be 20. So let's mark. Why it is not marking? Okay. Okay. Now the ruler should be marked here also. This is 0. The 0 should be the origin and we will mark. Okay. Every unit we will mark. This is the unit. Okay. So now what we will do? So here it is 20. So let's remove the. Okay. So now what we will do? We will mark here. This will be your 10, 20, 30, 40, 50, 60, 70, 80, 90. So how much we have to go move till 80? So now this scale is fixed. Any problem? Girls
No.
and boys? No. And here it is starting from 10 to 20. So how many points we got till yet? 1, 2, 3, 4. So we will keep this 5, 10, 15, 20. Any problem?
No.
No. No. Now, they are saying the amount of solid is 10. So the first one is 10 and this one is 20. So we will see this is 10, this is 20. So this is our point. So let's remove this. Oh God. Let's remove this. We got one point. Okay. What is next? You say this is 13. Correct? So 13 will be between 10 and 15. Correct. This is 10. So it will be little up in 40. It will be little up like here. Got it? Oh.
Yes.
Yes.
Yes. Okay. The next one is 60. 60 will be 16. So this is 15. It is there. So it will be little higher in 60. Got it? Okay. Next.
Yes.
80 and it would be 20. Right. Okay, let's remove this. Now we have one curve. Right? So we will start from here and it will be the curve like this. Got it? So the how do the curve is formed? Okay. You cannot take all. Okay. You cannot take all the curves together. You need to take at least three. Yes, this will be the curve. You can connect all the dots through scale, or you want to connect like this. Let me help you. If you want to connect like this, that is also possible. Got it? So, in the question, they have said plot a graph of the amount of solubility against temperature. The next question, what does graph indicates about the effect of temperature? So, what does it indicates? When you increase the temperature, solubility will increase.
Yes.
Correct? Okay. Use your solubility curve to make an accurate estimate of the solubility of solute at 52 degrees Celsius. So when you are plotting it, you may plot in graph paper. You heard about it? Graph paper?
Yes.
Yes. So there,
Yes.
yeah. So in the graph paper, there will be several divisions. Okay. So you need to count two. You just need to make one point here. So the temperature will be 52, and then you have to go to this line. So then you have to calculate this point. So I guess it would be 14, right? 14 point something, 14.5. So the what will be the solubility at 52 degrees Celsius? It would be 52 gram per 100 gram water. Got it?
Yes.
What do
Yes.
you think? These questions are difficult or they are need to be understood? It has to be understand. No, the questions are not difficult. They are just coming like this. Right, sir? Oh my God, it's 11:50. The class is over. Oh, I hope you enjoyed this class. All of you got scared of this question. Say something.
Um. mm,
Do you
Not
like this
really.
question? Okay. Do you like this question?
Not really.
So it is in between. You have learned something today. I hope you will keep learning. So tomorrow we are again meeting and at the same time. So bye bye. Take care.
Bye. You too.
Mm.